Okay, so I'm going to repeat what Connor just said, so Caitlin can hear this too. We have the difference between surface area and volume. So surface area would be like the outside covering. So if you're thinking about like a piece of candy with a wrapper or maybe a present or something, surface area would be like the wrapper or the paper that's surrounding it. Volume would be like the amount of space inside of something. So we're finding different parts. Volume, the units are going to be cubic units. Let me get the marker going. So volume is like the space inside. The figure, we're talking about cubic units when we're describing it. Did you guys ever in the past, maybe like in elementary school, have to like have these little cubes and like fill them in and see how many like cubic units a rectangular prism would be and whatnot? So for this rectangular prism, the cubic units would be, well, there's 6 across this way and 4 back this way. So how many would be on that bottom row? 24 would be on that bottom row of that, correct? 6 by 4. And then how many rows of those do you have? 2. So how many cubic units would be 48? Oops, units cubed. Okay, this works this way for the volume of any prism. If you find out how many cubic units are in the base, or how many square units really would be in the base, and you multiply that by how many kind of rows or units high it is, you're going to have your total volume. So I'm sure in the past you guys did rectangular prisms, and your teacher probably said like volume equals the width times the length times the height. Does that look familiar to anyone? You just take those 3 dimensions and multiply them together. Most everybody's shaking their head yes. A couple people think no. But that's how you could find it for a rectangular prism. This formula I'm going to give you works for any prism. So a pentagonal prism, a triangular prism, whatever type of prism. If you find the area of the base times the height, you'll have the total volume. So remember, capital B is area of the base. And this would just be times the height. So this formula still works because the base would be a rectangle, and you could multiply length times width to get the area of that base, and then how many units high it would be. So we'll go through a couple examples. Make sure that you're thinking about like what shape is the base. So for this prism, what shape is the base? The pentagon. Yep, the pentagon is the base, and they were really nice here. They just gave you the 2 pieces of information that you needed. So you didn't have to solve for anything here. There may be some that you do have to solve, but for this one here, they give you the apothem and they give you that side, so you can use that side to find the perimeter. So the area of the base is going to be half the apothem, so 3.4, times the perimeter of the base. Each side is 5, so the perimeter would be 25. So I'm going to just multiply that together on my calculator. The area of the base is 42.5, and that would be millimeters squared for the area of the base. And then what I'm doing is I'm thinking about like having stacks of those 8 millimeters high. So I would then take that for volume, the area of the base times the height, so 42.5 times the height, which is 8. So the volume would be 340 millimeters cubed. Questions so far? No? For this next one, we have to pay attention to what the base is. What shape is that base? the triangle. So make sure that when you're doing this, you're finding the area of the base. When I look at this, I think about like a bunch of triangles stacked up together. You know, the triangles are kind of stacked this way, and then you get your three-dimensional solid by stacking up those triangles. So if I wanted to find the area of this base, I am missing part of this. This piece is 15. Could I find that side there and then use that to find the area of the base? Okay, we're going to do Pythagorean theorem, so I'm going to take the square root of 15 squared minus 9 squared. So this side here is 12. So the area of the base is going to be the area of that triangle. How would I find the area of that triangle?
12 times 9 divided by 2.
Okay, so half of 12 times 9, or you could do 12 times 9 first and then divide by 2. Doesn't matter. What's the area of the base? 54. And the height of the prism, how far is it in between those two triangles or those two bases? 10. So then you have the area of the base times the height of the prism, which is 540, and that'll be feet cubed. Good so far? Again, if you can do surface area, this shouldn't be any harder because we're still finding area of the base. It's even like a little less steps than surface area. So the formula for this is exactly the same. The area of the base times the height. Except now, what shape is the base? The circle. So area of a circle is pi r squared times the height of the prism, and that's going to be the way the formula looks on your formula sheet. So looking at this picture, do you see that they have that whole line drawn in? That's telling you that the whole thing's the diameter. So make sure that when you're using the formula, you get the radius. The radius would be half that diameter, so 4.5. For volume, the height of the cylinder is the distance between those two circles, even if it's kind of laying on its side. The height would be 5. So I'm going to type into my calculator pi times 4.5 squared times 5. Just grab your calculator quick if you haven't already done so. Okay, you should get about 318.1, and that's going to be cubic inches. We're good? If you notice the volume for this stack of pennies in the cylinder, you think about like one of these pennies just being kind of like a flat circle. You could take the area of this and multiply it kind of by how many there are or how many units high that is. That would be your volume of that cylinder. And then if you take this and you kind of like shift it over to the side to where they're stacked like that, you'll notice that the volume does not change. It still has the same height if you were to measure straight up or straight down over here, and the area of each of those circles is still the same. I haven't taken any of those out. I could even like make this kind of look like that. Still has the same volume as just the original cylinder. Okay, and then the last thing, Cavalari's principle says that if you have two solids at the same height, and they have the same cross-sectional area, at every level, then they have the same volume. So just like that little penny demonstration, you know, all the cross-sectional areas, all those circles are the same area. It's going to have the same volume even if it's like tipped to the side. Surface area does not work out the same way. We had to do surface area of only right prisms. It gets more complicated if you do more than that, but for volume it doesn't matter. As long as they have the same cross-sectional area and the same height, it won't matter. Okay, and this is not entirely there again. That's so weird. Okay, there it is. Okay, so for this one here, it gives you the area of the base. Once in a while they'll do that for you, other times you're still going to have to find it. But this is still just going to be the volume equals the area of the base times the actual height. It's not times the slant height, but they don't give you the slant height here. They give you the height, and they give you the area of the base. So this question here will just be typing a couple things into your calculator. 17.3 times 6.4. Just grab your calculator and multiply those out. The volume would be 110.72, and that's cubic centimeters cubed. So any questions? Again, hopefully this is a little easier than some of the surface area stuff that we've done. You guys have